Hey, grade 8s, here are the solutions for the simple machines practice questions, the 6 of them. So we're just going to go through them briefly here. Hopefully this video only takes about 10 minutes to make, and then we are set to go. All right. So question 1, explain who is doing more work and why. A bricklayer carrying bricks and placing them on the wall of a building being constructed, or a project supervisor observing and recording the progress of the workers from an observation booth. All right, so this one here we're just going to talk briefly. Work is defined as a force applied to an object, moving that object a distance in the direction of the applied force. The bricklayer is doing more work. All right, so they're doing more work because they are applying that force to an object. All right, so we'll just put a definition briefly here. Work is force applied to object over distance. All right, for those fans of The Office out there, why use more word when few word do trick? But also, though, too, this is just a shorthand of saying a work is when a force is applied to an object over a measured distance. All right, so the bricklayer is doing more work. Okay. Question 2, how much work is done in pushing an object 7 meters across the floor with a force of 50 newtons and then pushing it back to its original position? How much power is used if this work is done in 20 seconds? All right. Now, we know that work is force times distance. So let's just write out our variables here, which is our force is 50 newtons, and our distance is 7 meters. But be careful, is my distance just 7 meters? No, because across a floor and then pushing it back to its original position. So it went there and then it went back all the way to point A. So that we have to put times 2, which means our distance is 7 times 2, which should be 14 meters. All right. We are ready to do the math now, which will be 14 times 50, because work is equal to FD. Work equals 50 newtons times 14 meters. All right, we know that 50 times 2 is 100, and we know that 100 times 7 is 700, so our work is 700 joules. Switching colors here, and then it asks us how much work is done. All right, and power is calculated by work over time. So work over time, the time they give us is 20 seconds. We already have our work value, so we will just plug that in. 700 joules over a time of 20 seconds. Power equals 35 watts. All right. Number 3, using a single fixed pulley, how heavy a load could you lift? Since a fixed pulley has a mechanical advantage of 1, it will only change the direction of the force applied to it. You would be able to lift a load equal to your own weight minus the negative effects of friction. All right, so that's just a brief description on that. So we'll just put your own weight minus friction is number 3. Question 4, give an example of a machine in which friction is both an advantage and a disadvantage. All right, So one answer might be the use of a car jack. The advantage of friction is that it allows a car to be raised to a desired height without slipping. The disadvantage of friction is it reduces efficiency. All right. So we will just put a negative in brackets, and we will say this is our negative, or our disadvantage. So reduces efficiency. All right. And then I will switch to green because it seems like a positive color. And we will say that, again, I said the advantage of friction, it allows the cars to race to the desired height without slipping. So car jack, raises car without slipping. Still need to be careful, but it is able to hold the car up instead of spending thousands and buying a hoist. All right, why is it not possible to have a machine with 100% efficiency? So big reason here, in big letters, is friction. All right, friction lowers the efficiency of a machine. Work output is always less than work input, so an actual machine cannot be 100% efficient. So we will say work output, and we will just put in an inequality sign. Work output is always less than work input. So you'll never get 100% efficiency. Oh, better extend my page here. And what is effort force? What is work input? Explain the relationship between effort force, effort distance, and work input. All right, the effort force is the force applied to a machine. Work input is the work done on a machine. The work input of a machine is equal to the effort force times the distance over which the effort force is exerted. All right. That is the solutions to the 6 practice questions from yesterday. Please wrap those up. Tomorrow we're going to have a little simulation to work with, and then we'll have an assignment coming out tomorrow or Friday, and then that will be our wrap up to the week. All right. Hopefully you've learned. Seems like you're learning a fair bit if you have watched both lectures, read through the slides, or that first video day on Monday with the video. I'm sure you're learning lots. There will likely be a little wrap-up question just to see how you're on Friday, just to see how you're understanding some of the stuff we've covered this week. Have a great day. We'll catch up with you later.